Well, today we are going to start in on chapter 3. We're starting in the actual math-related, you know, math-feeling parts of statistics with some actual calculations and stuff. Um, Today we're going to talk about measures of center. I know I mentioned this in class on Wednesday. I can't remember anymore if I mentioned it on Monday or not, but in descriptive statistics, one of the primary things that gets reported is some sort of measure of the center of your distribution for your sample. Um, we measure the center in a few different ways depending on what's appropriate. Okay, there we go. Uh, the most common are the mean, the median, and the mode. And depending on what our distribution looks like, one or the other might be most appropriate. So let's start right in. A sample mean is the arithmetic mean of a set of sample. We probably all know this by more commonly by the average. It's the arithmetic average. In statistics, it gets called the mean instead. Why did we change the name? Apparently because we're mean. So that is just the sum of the values in your data set divided by the total number. We typically denote it with a, get my laser pointer back here. There we go. We typically denote it with the bar over the top of the value. So x with the bar over it is the mean value. So sum up all the individual values, divide that sum by the number of data points we have, and that's our sample mean. The population mean is if we have the data for the entire population, we add those up and divide it by the number of data points in the population, and we get the population mean, which is given with a, in this book, with a mu, in Greek letter mu, instead of a x bar. I'm sorry, I'm a little bit thrown because I've got one screen that should be displaying, that's giving me a display with notes and what the slide should say, and it is still showing me the sample mean slide instead of the population mean. Okay, well, let's move on. Uh, oh, that is just weird. It's still on the sample mean. Okay. All right, so if we survey some students to find out the number of hours they sleep per night during the semester, um, there's their self-reported responses, so 5, 6, 8, 10, 4, 6, and 9. Somebody is lucky. Wow. Okay. Yeah. Um, let's calculate the mean. So, how do we do that? Take a minute and do that. We give you that so you can write it down. Uh, Unpause when you're ready to continue. Okay. So we add those values together and divide by 7 because there were 7 values. Round to 1 decimal place since the data values are whole numbers. Okay, about 6.9. Okay, to do this on a calculator on the TI-8384, let's see, I've got the simulator for that on my phone, so let's do that. There it is. No, I don't want to rate it. Press the stat button. Choose option 1, edit. And press enter. Enter the data in L1. Let's see, this was 5, 6, 8, whoop. Back. 5, 6, 8, 10, 4, 6, 9. Oh, I've got that in there already. Okay, oh, that's right. I enter the data, press stat again. It pulls up that display, not that you can probably see that. Choose calc. Choose option 1, var stats. Press enter twice. I get the solution when I hit enter once. Okay, so there, that first value there on the list is our sample mean. It gives a whole bunch, the sum of the samples, the square of, or the sum of the samples squared, the sample deviation, the population deviation, number of samples. Used this a few times. Okay, we can also use the mean to find a value. So if you know the average cost of a song, for example, and you know that 4 of the songs cost $129. You've got 5 songs, so 4 times 129 plus X, whatever the last song is, divided by our 5 songs. Right, it's turns into simple algebra. Okay, right, following. There we go. So here's our formula for the mean. We've got 4 songs at 129. 1 song we don't know. 5 songs. What was it? 123 was our 123 was our average. There we go. $0.99 for the last song. Okay. The weighted mean is basically the mean, again with some sort of weighting factor that gives it a relative importance. So, for example, in our grade calculation, you could consider your final grade a mean score. Excuse me for a moment. Oh, excuse me. Okay, you could consider your final grade a mean score. So what the homework was worth 20%, if I remember right. So homework score times homework weighting plus test 1 times the 11% that test 1 is worth plus test 2 times the 11% that's worth, all the way up to the final times 25%, divided by the sum of the weighting factors. So in this case it'd be divided by 1 for 100%, would give us the weighted mean grade. And here we go. This is a fairly useful concept in terms of figuring out, say, as you'll see in these examples, what you need to get on your final exam to get the grade you want. Okay, so we've got 40% of the grade is tests, 20% homework, 10% quizzes, and 30% final. All right, so here are Walter's grades so far. Or these are what Walter's grades are. So we need to calculate his final grade. So why don't you take a minute, write these down. I'll flip back to the other slide, pause for a minute so you can get the percentages, then do the calculation and unpause when you're ready to proceed, okay? Back. Okay. Um, all right, and here are Virginia's grades also. So, give a moment for those. Okay, so let's do our solution here. Hopefully you've all got this, and it is going to step through this somewhat again, so you should be able to follow the logic and see if you've done something wrong and why, where. Okay, so Walter's test average of 83 gets a weight of 40%. Weights are the percentages for the categories. Values for X are Walter's grades in the categories. Right, so there's our formula. So test grade, test weighting, I think that was homework grade, homework weighting, quiz grade, quiz weighting, final grade, final weighting, sum of the weightings down here. Right, so if you do that calculation, you get 87.9. So his final grade would be 87.9, so in this class that would be a B. Alright, so here are Virginia's grades. And they did this one with the TI. So, okay, so we need to enter 2 lists of data instead of just one. I did not do this calculation yet. Press stats, choose edit, enter. Stat again, choose calc. Let's see. So put the x values in L1, weights in L2. Stat, calc, var stats, enter. Press second 1, comma, second 2 to enter L1, L2 on the screen. Stats, var stats. Oh. Stats. Edit. Edit. Okay, so for any of you who are not familiar with the calculator, if you hit the little arrow on the keypad, it will switch which column you're in, so you can put things in L2 by going over. So I'm not going to do the whole calculation right now. Let it move on. The output then gives us the weighted average. So if she's predicting she gets a 90% on the final, she'll end up with an 80.6 on her final grade. So let's see what would happen if that inverted, if she did poor on the test but really well on everything going up to it. So here is another student who's not done very well on the assignments and semester project, not so well on the tests, and hasn't taken the final, doesn't know what she thinks she's going to get on it yet. So the question here is, the real question is, if she wants to get an A, the minimum value to get an A would be 90%. If she wants that A, what does she have to get on the final exam to get that A? And what would she have to do to get a B? Okay? So this is a lot like the finding a value when you know the average, in this case, we've got 90% is our desired average, and the grade on the final is what we don't know, right? The only complication we've added is those weighting factors. Okay, so we've got, this is everything going up to the final. The denominator isn't equal to 1 because we're missing the final exam still, so that if we added the final in, it'd add that. So she's got an 86.9 going into the final exam. Okay, so if we add in the final and set it equal to 90, it's her desired grade. So there's our final score that we don't know, the 10% of the class that the final is worth. Added that in down there too. And do the algebra, we get 117. So if she managed to score 117% on the final exam, she could get an A. So that's basically telling her that she can't get an A at this point. If she scored 100%, she would end up getting an 88.25. If you want to do the calculation, you can. So if we set this to 80% instead of 90, again, we set it up the same way, except we use 80% instead of 90 here. She only needs to get a 17% on the final to land that B. So, from this fairly simple calculation, knowing what she's got going in, it's fairly easy for her to see what she needs to do on the final to either maintain or improve her grade. Okay, the next possible measure of the center of a data set is the median. So the median is the center value if we had the data ordered from low to high. If the data set is an odd number of values, it's the middle value, period. It's fairly simple then. If we've got 1, 2, 3, 4, 5, the middle is 3. Gets a little bit more complicated if we've got an even number of values, then we take the average or mean of the two middle values. So if we had 1, 2, 3, 4, we would average 2 and 3 and get 2.5, and that would be our median. Yeah, and yes, 2.5 is not actually one of our data points. It would still be the median. All right, so if we have these two samples, what would the median be? Remember, the first step is to put these in order and find the center point. So unpause when you're ready to proceed. Ooh, excuse me. Okay, here we go. We put them in order. There's an odd number of values, so we get 6. The median for that one is 6. There's 8 in the next one. If we put them in order, we're going to need to average the 7 and 8. There's the 2 in the middle. 7.5. Okay. I'm going to skim over the calculator method. I've uploaded the slides, so you can look over that. I believe, yes, glancing over at the textbook, it is also included in the textbook. So I'm not going to spend time going over that here. One thing I will point out is you do get these statistics. You will need to scroll down using the arrow button until you find the median. Okay, the last measure of the center is the mode. Um, no, not Edna mode. It will not tell you not to wear capes if you're a superhero. Um, it's the value in your data set that occurs most frequently. If the value occurs only once, or if every value occurs only once or an equal number of times, there is no mode. If only one value occurs most often, it is unimodal, uni for one, like unicycle. Um, if two values occur equally often, it's bimodal, like bicycle, bi for two. If more than two occur equally often, the set is said to be multimodal. Okay, so we need to find the mode of these sets, or actually, no, we don't need to find the mode. I just need to, sorry, yes, find the mode, state if it's unimodal, bimodal, or neither. And go ahead and unpause when you're ready to see the solutions. So again, it's easiest if we put these in order. And you can see that there's 2 6s and 3 7s, so mode is 7 and the set is unimodal. There's only one. In order, all the values only occur once, so it is neither unimodal nor bimodal, and there is no mode. So again, we sort this data. We've got 2 2s and 2 7s. They occur an equal number of times. So modes are 2 and 7, and the set is bimodal. The last set was already sorted. All the values occurred twice, if I remember right, and so again, there's no mode, and it is neither unimodal nor bimodal. TI-8384 Plus will not calculate the mode for you. Excel will. We can talk about how to do this in Excel in class if you all want. I will try to remember to ask about that on Monday and Wednesday. Okay. So we've got this data set of the ages at which people truly retired. Quit being a greeter at Walmart or whatever they did, when they were truly done working. So we want to calculate the mean, median, and mode for this data set. Take a minute and do that, and unpause when you're ready to proceed. Okay, so our mean is simple arithmetic average. We get 75.3. I do want you to take a moment and just look at these values and look at how many of them are below 75. It's just the one. One of the potential problems with the mean is that a tail, an outlier that doesn't fit with the rest of the data can really skew the result in a mean. So outliers have an outsized impact on the mean. Okay, we have an even number of values, so we need to find the middle two values, put them in order. There's our middle two values, nicely highlighted. We get 79.5. All right, the mode. In this case, they put it on a dot plot for us to make it easy to see, and also easy to kind of see the distribution. We've got 80 as the mode. They went ahead and marked the outlier, the mean, and the median. You can see that the mean is really strongly affected by that outlier, and neither the median or the mode really are. Okay, so in general, if you're dealing with qualitative data, the mode should be used. If you're dealing with quantitative data, the mean should be used unless it's got outliers or is skewed. If it is skewed or outliers, you need to use the median instead. All right, I'm going to pause for just a moment. Okay, so we have a few example data sets here. T-shirt sizes, small, medium, large, extra large. This would be qualitative data. It would be an example of that. So based on our discussion we just had, what would the appropriate measure in the center be for that? Salaries for a professional team of baseball players. Again, what would be the appropriate measure for that? Prices of homes in a subdivision with similar homes. Professor rankings from student evaluations on a scale of best, average, and worst. So, appropriate measures for these. Okay. T-shirts are ordinal, meaning that they're qualitative, but there is an order to them. But since they're qualitative, best measure is the mode. Player salaries are quantitative, but there's going to be outliers because there's going to be those superstars that they spent outrageous amounts of money to get. You know, these are baseball players, I think, and the only example I can come up with off the top of my head is LeBron James, and he's not baseball. So, yeah. But the median is the better choice here. Home prices are, again, quantitative data. These homes are similar, so they should probably have the same, similar prices. There aren't likely outliers, so the mean is probably the best choice. Again, we've got qualitative, it's ordinal data, so the mode is appropriate. There are some interesting, if you think about these in terms of where they are on a graph of the distribution, the mode is the data value at the peak, or peaks. There can be multiple peaks in a distribution, possibly. The median, just like there could be multiple modes, the median is where the area is divided in half, and the mean gets pulled towards any outliers. So, take a moment and identify mode, median, and mean on this. See, skewed that the tail is that way, so it is right skewed graph. And proceed when you're ready. Mode is located at the peak, so that would be line A. Median divides the area in half, so that is line B in this. And the mean is skewed to the right, or sorry, the distribution skewed to the right, so the mean, the measure of center that's pulled farthest to the right is the mean. That would be C. It's a little hard to visually estimate where the area is cut in half, so you can kind of do that by process of elimination. This is the one that's been pulled in the direction that's skewed, so the median is left. Okay, so general properties. Mean is the average. May not be a data value. May not be a number that was in our list. It is a single value. It is strongly affected by outliers. It's used for quantitative data with no outliers. Median is the middle value. Again, may not be a data value. Just one value. Pretty much immune to outliers. Used for quantitative data with outliers. The mode is our most frequent value. It is the one that has to be a value from our data list. it can have multiple values or none at all, and it's not affected by outliers, and it is used more for qualitative data. All right.